These are notes.
Oh, you're right.
Write them down, sit back, print them out later. I don't care. Learn it.
Last year.
There's 3 more outlines there if you want to look at. There's a couple of biology course outlines as well. Okay? Ask a brother or sister, or a friend's brother or sister, whatever. Ask them what science at the university is like. Okay. So, as I indicated earlier on projectiles, basically I'm going to spend 3 days doing sample problems, probably a day or so of sort of work. We're going to do a few days of labs, and then write a test. There's not a lot to this unit.
Last year when we were in grade 11 physics, is this like the unit that they designated jump to, like the flaming food?
So after this one, this is sort of the introductory one. After this, you'll be able to solve problems where projectiles are launched off a cliff at an angle of 0 degrees. Is this a good picture for that? No, it's just a cool picture that I found. Is it 0 degrees? No. Okay, so again, I would encourage you, don't write everything down. It's all going to be there. Summarize, do what you need to learn it. The basic ideas of projectile motion are this. Number one for a reason. It's the number one thing. Vertical and horizontal motions behave independently of each other. If you can keep that straight, you're fine. Okay? But everything you do, ask yourself, have I kept vertical from horizontal? Have I added in an acceleration on a horizontal movement? Ask yourself that question. So that is, despite having a horizontal velocity VH, the projectile has the usual vertical acceleration of gravity, which of course is minus 9.8.
So is that always?
Always. Well, unless it happens to be on the moon or wherever, right? Not a lot of projectile motion questions on the moon. They generally happen on Earth. Do not use acceleration horizontally. Do not use acceleration horizontally. The converse of that is that VH stays the same at all times. Horizontal velocity remains the same at all times. The downward acting force of gravity does not affect the magnitude of the horizontal velocity. Gravity does not affect horizontal motion. Right?
But I thought it was just the vertical didn't change. Now you're saying that.
The vertical acceleration doesn't change. Well, to be precise, the horizontal acceleration doesn't change either, but the horizontal acceleration is right?
What is the V?
Velocity. Velocity horizontal.
Oh, look at there.
Velocity, yeah, horizontal. Okay, so let's put on our thinking hats. A bullet is fired from a gun and air resistance is negligible. You can assume that in almost all situations the air resistance is 0. Just makes things easier. The muzzle velocity is 120 meters per second. That is a key term that you need to know. Please don't ask me on the day of the test, what do you mean by muzzle velocity, Mr. Bennett? You're going to see it over and over again. It means the speed that it leads the muzzle at, the initial velocity,
Oh.
the launch velocity. All different words meaning the same thing. It's 120 meters per second.
Yeah, I don't think you haven't set it up so we can.
No, I don't think I have. How far away will the bullet land if it takes 2 seconds to hit the ground?
Oh.
How far away will and it's really as simple as it. In fact, you could probably do it in your head. How far away will it take if it takes 2 seconds to hit the ground? So the bullet goes like this. That time is 2 seconds. How far away?
How do you know that? Oh no! I have something
I always remember once I've started. 409, right? How far away? It's going 120 meters every second. How far does it go in the first second? How far does it go in the second second? For a total Zach of? Press enter. Yeah, I know.
He's just not even his own person.
Yes, the answer is B. 120 in the first second, 120 in the second second. 240 meters. 240. Right? How far? 120 meters per second. 120? 120. Okay. I've given you this. Do you really get it? A rock is... Let me start it here so you can answer. Here's a picture of me. I'm at some big gorge and I'm throwing a rock off the edge. Hopefully there's no one down there to... A rock is thrown off a cliff at an angle of 30 degrees and a speed of 10 meters per second. At its peak, what is the vertical acceleration? Read carefully. What is the vertical acceleration at the peak? Final answer, Regis. No, you cannall call a friend. I'd take this audience over some other audience. What is the vertical acceleration at the peak? That's S squared, meters per second squared. Correct answer is, my friends? Yeah, gravity. Vertical acceleration. Does the vertical acceleration turn off when it reaches the peak? No. The vertical velocity is 0. The acceleration is always minus 9.8. Why would what? I don't know. I've ran out of ideas. I guess. No, I've indicated that it's on Earth. Here we have the same rock thrown off the same cliff, which is on Earth. And now I'm asking you for the horizontal acceleration.
Is air resistance?
Neglect air resistance. Horizontal acceleration.
I'm gonna take a risk.
A risk?
One friend.
One a nerd.
Too late for that. I'd rather go back. It's a lie.
Depends on your friend.
Yeah.
Yeah, it should be like set up on Google, just like ready to go.
Yeah, that's what I would do, yeah.
Oh.
Correct answer is D. Why is it D?
Because it's accelerating.
Horizontal acceleration is always 0. It doesn't change its... Have I been saying the same thing over and over again?
I should put that somewhere, but I'm talking about
Okay. Here we have, I'm going to do a sample problem for you now. A car with an initial horizontal velocity of 20 more meters per second goes over a 45-meter high cliff. Now, you'll see here, this car has somehow managed to magically jump into the air. That's just a picture because it's cool.
Like across a 45-meter cliff?
So, what you've got is this.
horizontal acceleration always equals 0, like forever. Like
Yeah.
all,
Yes.
all the time.
Yes. Unless I say otherwise.
Okay.
Okay, so Thelma and Louise, I realize I'm spoiling the movie, but at the end of the movie, they drive off the cliff. What is their launch angle? Big fat 0. Right? They just drive off the cliff. You want to do this. This is a sample problem.
This is important.
Oh, what's the question?
I haven't given it to you yet. I'm just telling you that the car is driving at 24 meters per second, and the cliff is 45 meters high. Okay? What kind of questions do you think I'm going to ask today? What can I ask you?
I need to write the question.
How long will it take you to the ground?
How long will it take? How fast is it going when it hits the ground?
Like the then or what?
Yeah, kinda. Would it not be just 24?
We don't
Yeah, it
know.
would be.
No.
Would it?
No, vertical has nothing to do with horizontal.
But when we say how hard does it hit the ground, we mean how fast is it going horizontally and vertically, don't we? Because like when it hits the ground, it's going to be going at an angle, right?
Yeah, that's what I was getting for. The vector addition.
Vector addition, right?
Ah, by components.
What might be one other thing that I might ask? I might ask how long it takes to fall, and I might ask, I'm hinting you, how far away? Now, generally, if you're doing like a CSI crime or accident reconstruction, you would likely measure how far, and that would tell you how fast you were going, right?
Yeah.
Whether or not you tried to brake before you went off the cliff or something like that. Okay. So, here is the question. Can I go on?
Yeah.
The question is, find the time of fall. How long does it take to fall? What's the number, 24? Does it matter if the car is going at 24 meters per second straight, or if we just drop the car off the edge of the cliff? Jason says no. Does the car that's going 24 meters per second sideways take longer to land? Jason still says no.
All right.
And we don't know.
Right? Exactly, Zach. We watched the Mythbusters video. They shot the gun. They dropped a bullet. They landed at the same time. It doesn't matter. It doesn't matter. So how do we find the time of fall? What is first step? Break it into components. What's the horizontal component? 24. Why is it exactly 24? Because it's how fast he's going horizontally. There's no angle. What's the vertical component? 0. The vertical component at the start is 0. It's not going vertically, it's just going
Oh,
flat.
what fall?
Will the vertical component change?
Yes.
If you drop the ball,
Yeah.
yeah, of course, the vertical component will increase, right, due to gravity.
So why is the Earth is on the cliff right now?
Yeah, it hasn't left the, it's
Oh.
only going it's only going,
You're just really.
it's only going sideways, right?
Oh,
Is it like Wile E. Coyote? Does it go way out like this and then look down and then go? No, as soon as you leave the cliff, it goes down.
Yeah. So he hasn't left the cliff.
Right?
Okay.
What's the acceleration horizontally?
0.
What's the acceleration vertically? Okay, now we want to know the time of fall. Which of those do I use, the VH or the VV? Time of fall. VV. Right? The time of fall is dependent upon how fast it's going vertically at the start. So, I know the distance vertically, right? I know the distance vertically, and I know the initial velocity vertically, and I'm trying to find the time. So which one has all those things in it? Do I know enough in there?
Yeah.
What's my distance? What's my initial velocity?
0.
Hannah is correct, 0.
Yeah.
What's my vertical acceleration? Do I have an uh-oh? Do I have an uh-oh?
Negative time.
Negative time?
We'll just change
The Rudy.
The Rudy.
Yeah.
Yeah, but how do I make it work without just sort of doing it?
Oh, you have to get him a negative root.
What? Does it really matter? Well, does the 9.8 have to be negative?
Well, it is down.
But we don't have another direction.
Think the reverse of what you just said, Ryan.
Displacement can be negative.
Why not? Because is the displacement not Yes, it is.
Ooh, what?
Okay? The D is down, so it should be negative. That's what makes it work mathematically.
So would it be wrong if I just left both positive?
Not necessarily, but be aware that when things start going up and then down, that you have to deal with that.
So what happens here?
Okay, so you're going to have minus over minus, which is positive, and so what's my time?
So now
It's
the
gonna be
distance
okay,
is
right?
displacement?
It always has been, actually.
Has it been?
Yeah, it really has.
I would make it a negative in brackets because it's going down.
Well, yeah, but that's what I didn't understand. It's like, you're using the horizontal.
I get 3.03 seconds. Again, it doesn't matter that it's going 24 meters per second horizontally. Could it be going 1,000 meters per second horizontally? Yeah, it would still take, if I took a bullet, if I took a rifle and shot it off the cliff, would it go farther? A bullet. Yeah, it's going a whole lot faster. Would it take any longer to hit the ground? No, it wouldn't. Because it doesn't matter how fast it's going sideways. Now, the next question is, how far from the base of the cliff does the car land? Okay, this is sometimes referred to as the range. The range is how far away. How far from the base of the cliff does the car land? Note, the horizontal component VH and the time in the air determine the distance, right? How fast you're going determines how far you go, and how long you're in the air determines how far you go. What can I do for you, Joey? You may. Joey, does the horizontal and the vertical and projectile motion, should we keep separate or should we put them together?
Keep separate.
There you go. See? Joey, listen.
How Joey? We
You
saw
did
it.
awesome.
Yeah, it was about 2 pieces. Like,
Some people have, more extensive cheat sheets than others. Joey just didn't need one.
poor Joey forgot about it. Actually, that-
So, how am I going to figure this out?
You write down that note?
Yeah, if you want. It's up to you. Does the VH remain the same? Yeah, it does. It stays at 24.
Is there a way to do that question without, like, can you do it like the D equals VIP equals 1/2?
Well, you have 0 acceleration, so this is really the same. I was breaking it out, right?
Yeah, he's right. You could use that, but then because the acceleration is 0, and what do you end up with? V times T. It's the same thing, right? Well done.
What's the V bar formula? How do you find V bar?
V bar is just average velocity, but if it's constant, right? If it's a constant velocity, which it is, then the average and the velocity are the same.
How can it be a constant velocity if it hits the ground and it's gonna...
No, as it flies through the air. As the car goes flying through the air, the horizontal velocity remains the same.
Yes.
Jake, what's the horizontal acceleration for a projectile? Come on. Horizontal acceleration.
Well, it depends. Is there air resistance?
There is no air resistance.
In that case, it's 0.
Thank you. Vertical component, vertical acceleration?
Whoa, wait, Jake.
Well, it depends. Is there gravity?
Yes, there's gravity.
Is there also air resistance?
There is no air resistance.
That is negative.
Very good. You still get your credit.
Whoa, get out of there. Bunch of sucks.
They practice. They've done lots of these questions. They get it. You gotta practice. Okay. What is the velocity of impact?
Is that it? Okay.
No? Well,
No, but the other question.
now, this is what John was asking. How hard does it hit the ground, right? How fast is it going when it hits the ground? What you're really saying is, what is the velocity at impact? Note that it has two components, horizontal and vertical. What is the horizontal? Still 24. What's the vertical? Is it 0? No, gravity has accelerated, right? Do we know how fast it's going vertically? We sure can. What could we use?
Oh, I guess we can't do that.
Yeah, or the grade 12 version of it, which is this one, right? Final velocity is initial velocity plus a times t. So the final velocity is the initial. What's the initial vertical? Yeah, what number, John? What's the initial vertical? 0. What's the vertical acceleration? $29.69. Ah, correct. Negative. So it's going 24 meters per second horizontally. It's going 29.69 meters per second vertically. How do I find the total? Do I just add those together? No, it's vector addition. One is horizontal, one is vertical. It keeps coming back to vector addition. Same concepts over and over again. So what's it going to be? 24 squared plus 29.69 squared.
Where's the 24 squared? Oh, God.
Horizontal. Yeah.
That's cool. Wait, so what would the formula be? I want to do that first, just so I know my beats. It's VH plus VF? Why would it be?
VF equals VI plus AT.
No.
Here?
Yeah.
This is just Pythagoras, right? V squared equals VH squared plus VV squared.
Yeah. But then
Just-
what happened with the VF? Is it the result?
Oh, the VV is, right? Well, this is equal to, no, this is okay, Hannah. The VF is equal to the vertical, it's the vertical component of the velocity at impact. That's what it is. That's not right. I don't like this calculator.
Well, that was the new kind of calculator. I don't like that one. Oh, because you can't square root it.
Yeah, I don't like that.
You have to delete the number and
I know, I
put
hate
it
that.
first. Yeah.
No.
38.2. It's going 38.2 meters per second when it hits the ground. Do we need anything else here? Yep, why? Because it's a velocity. And velocity is a vector. Opposite over adjacent. Opposite. Adjacent.
51 degrees.
Ah, good question. Which way?
East 51 north.
Nope.
North 51 east.
Nope.
Oh, south, sorry. We're not.
What did you get? I got something stupid here. Oh, I'm in radians. Who puts calculators in radians?
Mr. Ray.
51.
51 south.
Sure. Nope. It's 51 degrees because I wasn't given east, south, any of that. Remember, it's just hitting the ground.
Right.
Right.
Below horizontal.
BTH, below the horizontal.
What if it was going left?
Doesn't matter, right? It's just below the horizontal. It's at the angle of impact. Excuse me, we call that BTH, below the horizontal. BTH. Remember the 7 problem types from the other day? Those of you that weren't here might not remember them, but there were 7 problem types. So what I'm showing you is ones that are like that, right?
Oh, David Letterman.
Dave has I was sitting there watching Letterman the other night and I got thinking, you know what? I've been watching Dave since I was your age.
Alright.
Like 16, 17, 18 years
How
old.
old is he?
Dave's old. That's how long I've been watching Letterman. And I thought, you know what? This is like, I now must be old because Dave is now going to be off the air. I must now be old. Anyways, Letterman used to, I'm guessing, he did this the other night actually, shoot stuff off the roof, right? He used to do it all the time. He used to throw watermelons off city building. If he throws a watermelon off a 25-meter high building at a speed of 1.5 meters per second, how far from the base of the building does it land? Work that out for me to 1 decimal point. And then I'll show you the video of Dave Letterman throwing stuff off a building. 6 people got it.
Well, the 3.5 because it was rounding. It's just 3.45, so I rounded it to 3.5.
We got 3.4.
If you got 3.45, if you put 3.5, I'll take it. I can't make the clicker take a range of, it's just got to be what it's got to be. Should I do this question?
Watch the video.
Yeah, I watched the video.
As long as there's time to watch the video.
Let me see what's next. Oh yeah, okay, we got time. Oh, we got lots of time. Let me do the question. Okay, so it's going to be D equals VIT plus a half AT squared. What's the distance? Minus 25. What's the initial vertical component? 0. 1/2 of minus 9.8 T squared. So T is equal to, and you got to be able to do that math like it's, I know how to do that. You can't stop and think about that. You have to just know how to do that. Practice, practice, practice. 25 divided by 4.9 square root. 2.26.
Also, I have a question. Why were we doing regular, like not negative 9.8 last year, and now we're changing it to negative? Shouldn't we have kept it the same?
We're going down.
Yeah, we were going down in proportion.
But I don't quite know if how I want to answer that. Does it matter here? Like sometimes it matters and sometimes it doesn't, Steve. Should we always use it? Yeah, we could. And I think I remember having this conversation with you. When you always use it, sometimes it just makes things way more complicated than it really needs to be. Right? So
And we'll never know.
it comes with experience. How do I know when to use it?
If you're using,
Because I've done these questions over and over and over and over because that's what I do. How do you know? You got to do questions over and over and over. And even if it's the same one over and over again, it just takes, there's no fast track, you guys. It takes practice. That's true with just about everything. What's the horizontal velocity? 1.5. We're solving for D. Our time is 2.26. I just take that number. I didn't clear my calculator. I don't clear my calculator. Times 1.5. 3.4. I got 3.388.
oh, that's
Right? I didn't clear my calculator here. That's how I get the 3.4. Brandy, we're 2 for 2. What's the horizontal acceleration for a projectile? Horizontal acceleration for a projectile. Horizontal acceleration.
So it remains constant,
What's the vertical acceleration for a projectile?
right?
There you go. See, the 3 for 3. They all took it last semester. They all practiced over and over, and they still know it.
There, so there goes. Perfect.
What are the 7 types? There's 2 beginning kinds. There's on straight ground. There's
Straight
up and down,
Snagglers.
at an angle. Off a cliff, there's drop,
Oh, thrown.
thrown,
Thrown up and then down.
up and then down,
Yeah, but it's horizontally.
horizontally,
And an angle.
and at an angle. So which one did we do today? We did this one. But you should be able to do all of those guys. Right?
No, it's in the building.
I will do this one tomorrow. And then when we return, I will do this one. Okay? So you have some practice problems there. They're basically all sorts, all jumbled up. So like they're not like a whole whack of like one kind or another. Oh, and I don't have the QR code or nothing on there, do I?
Oh, yeah, that's not gonna help us with anything.
Well, I'll make sure the solutions are up online. I'll have to make sure. I'll do that fix right now.
Well,
Do that?
But are we allowed to call freely?
I won't change the screen.
I don't know, I